All right, welcome back, Algebra 2. We're in Chapter 6, in Rational Exponents and Radical Functions. We're looking at 6.3 today, Function Operations and Compositions. So to start off with, we will have a warm-up. So you can pause the video and we'll go over these 4 questions in just a second. If we look at number 1 is 9x to the 2/3 minus 2x to the 2/3. And so in 6.2, we talked about rational exponents, anything to the 2/3. That doesn't really have much bearing on the actual problem that we're doing here. We have like terms here. So since they have both have x to the 2/3, the answer here is going to be 9 minus 2, which is 7x to the 2/3. Number 2, we're going to use our exponent properties. So we have 28x to the, I'm going to put a 1 there, to the first, divided by 4x to the 1/5. So I'm going to take 28 divided by 4 right here, and that's going to give me 7. And then I have x to the 1 minus 1/5. So I'm going to use my exponent properties and subtract those exponents. So 1 minus 1/5 is 4/5. And so this number, the second one is 7x to the 4/5. Number 3, we have, we're trying to find what is f of -6. So it says let f of x, I should say, equal 3x plus 5, and g of x equals 2x squared minus 7. Well, what is f of -6? So this is just function notation, where we're going to take -6 and we're plugging it into f. So instead of 3x plus 5, we're going to have 3 times -6 plus 5. And we're simply going to evaluate and then say what the output is. So 3 times -6, we have -18 plus 5. And therefore, this answer is -13. So f of -6 in this case is -13. Number 4 is g of -4. So again, that idea of function, we have an input and we're trying to find that output. So g of x is 2x squared minus 7. So we're going to have 2x squared minus 7. But my input here is -4. So I'm plugging in that -4 into the x. And then I'm going to evaluate this expression here. So now I have 2 times -4 squared, which is 16, minus 7. So this is going to give me 32 minus 7, and my answer will be 25. So g of -4 is 25. All right, so the first thing we're going to look at is operations on functions. And so we have this idea that if we have a function, right, and we use function notation, so I have f of x or g of x or h of x, then we can treat functions as kind of separate entities where we can add them, subtract them, multiply, and divide them. And so that's what we're saying here, is that if we have a function, or if we have 2 functions, we can just take, f of x. We can look at one function and another function and simply add those functions together, just like we would, any polynomial. And we've done a lot of these in chapter 4 and 5. We can add them together, we can subtract them, we can multiply them, and we can divide them. So here are just some simple examples here. If we have an f of x, if f of x equals 5x, and my other function, g, is equal to x plus 2, so we have an f of x and a g of x, well then if I said something like, what is f of x plus g of x, you would simply take those definitions, or take those, function definitions and add them. You'd have, 5x plus x plus 2, and then we can just combine our like terms. And so we'd get 6x plus 2. Now we can do the same thing with subtraction. We can do the same thing with multiplication, right? So we can multiply the 2 functions together, or multiply polynomials together. and we can also divide as well. And so that's what we're looking at in the first part of section 6.3. So a couple definitions that we've seen before. The domain are all the allowable input values that would output real numbered solutions. And the range is all the output values of the function. So we, again, with the idea of what a function is, the domain is all the input values or the allowable input values, and the range is simply all the output values. All right, so looking at example 1. All right, so example 1 gives us two function definitions, one for f and one for g. It says f of x, remember this of x right here, or this f parentheses x. This does not mean f times x at all. The f of x, just as a reminder, just means that whatever's in parentheses there, that's just the input, or how we input into the function. This f right here is simply a name. It's just the name of the function. And so what we're saying here is that we have a function f that's named f, and our input right now, or the input or the placeholder that we're using for the input right now, is x. So f of x, the definition of the function is right here at 5x to the 1/3. So when we go down to this right here, what is f of x plus g of x? It's really, looking at this problem, it's just a substitution problem. Well, f of x is equal to 5x to the 1/3, and g of x is equal to, so 5x to the 1/3 plus g of x is negative 11x to the 1/3, so we simply add those. And then we look at this expression that we have and we try to reduce it, or we try to simplify it. So since we have like terms, well, then we can go ahead and add the exponents. So we have negative 6x to the 1/3. And so that's f of x plus g of x. If we were to do f of x minus g of x, same thing. We're going to take f of x to the 1/3, but now minus negative 11x to the 1/3. So similar to the first one, but now since we subtract a negative, we're going to have 16x to the 1/3 there. All right, so that's adding and subtracting. So as long as we remember how to add and subtract polynomials, and we follow those rules that we've already learned in previous sections and chapters, then we're good to go. Looking at example 2, how do we multiply and how do we divide? Well, again, we've already done these types of problems many times before. We're just looking at it from a new angle as functions. So if I'm trying to multiply two functions and I have what is f of x times g of x, well, let me go ahead and use substitution again here. F of x is equal to 8x, so I'll take 8x, and I'm going to multiply that by g of x, which is 2x to the 5/6. And that's what f times g is. Now we're going to try to simplify this expression right here. And we can go ahead and now use exponent properties to finish this. So I know that a times 2 is 16. And I know that x times x to the 5/6 is going to be x to the, and I'm going to add these exponents. The exponents are 1 and 5/6. So I have to add the exponents. What is 1 plus 5/6? So I get a common denominator here. 1, I need a common denominator with 6. So this is actually going to be 6/6 plus 5/6. And that's going to be 11/6. So I have 11 over 6 here. And there is my answer. This is 16x to the 11 over 6. And then looking at division. right? So now I have, what is f of x divided by g of x? So f of x divided by g of x is going to be now 8x divided by g of x, which is 2x to the 5 6. And again, we look at this expression that's in front of us, and we rely on our exponent properties to simplify what we have. And so I have 8 divided by 2, and I know that's 4. And then I have x to the 1 divided by x to the 5 6. So now I'm going to subtract. I'm going to subtract my exponents, and I'll have 1 minus 5 6 is 1 6. So this would be to the 1 6 here. All right. So go ahead and practice some of these. You can pause the video and look at ABCD, and you can see we have new function definitions up here, and go ahead and try these 4 problems. Okay, so part A says, what is f of x plus g of x right here? There are kind of 2 different ways to write f of x plus g of x. Both are equivalent. So I could, this is the way that I typically use right here. If you say f of x plus g of x, we're really just going to add these 2 function definitions right here. But you might also see it as f plus g of x. And it really just means the same thing. We're taking the 2 functions and we're just adding them together. So part A, we'd have x squared plus 4x minus 3. And we're going to add g of x, which is 2x minus 3. And so I have these 2 things that we're adding. And so we know how to combine like terms. So therefore, my answer is going to be x squared. 4x plus 2x is 6x. And negative 3 plus negative 3 is negative 6. So there's my final answer for f plus g. Part B says, what is f of x minus g of x? So I'm going to do the same thing here. The only thing to be careful of in this problem is that we are subtracting the whole function. So this part right here, I'm not going to add the 2x plus 3. I'm going to subtract it like this. And I want to make sure this whole thing is in parentheses because I'm subtracting that whole function 2x minus 3. So when we do this problem, that negative right here is going to distribute into each term inside of that parentheses. So if we were to continue to write this, if we wrote this again, for B, we'd have x squared plus 4x minus 3, and now we have minus these 2 terms. So if I think of this as distributing this negative, I'm going to have minus 2x and then plus 3, because this subtraction is going to go into both of those terms in that binomial. So similar to A, but this answer is going to become x squared plus now 2x, and then plus 0, because negative 3 plus 3 is 0. So there's my answer for B. Part C is f times g of x, or f of x times g of x. So this is, again, goes back to chapter 5. If we take x squared plus 4x minus 3, and I'm going to multiply that by g of x, which is 2x minus 3, then I'm going to start multiplying here, and you can do that with, the box, or you can do that horizontally, you could do it vertically, or you could use a box method. But basically every single term of this red part is going to be multiplied by every single term in the blue part. So I'm going to do it a very traditional way, and that's going to be taking x squared times 2x. So what is x squared times 2x? Well, that's going to be 2x to the 3rd power. Right? I'm going to add those exponents and get that. Then I'm going to take x squared times, that 3. or negative 3. So x squared times negative 3 is negative 3x squared. So this is negative 3x squared. Well, then I'm going to go to the next term. So let me use a different color here. So I have 4x. Now 4x is going to be multiplied by 2x. 4x times 2x is 8x squared. So this is plus 8x squared. And then 4x times 3, or negative 3, is going to be negative 12x. So minus 12x there. And then we have one more to do, and that is negative 3. I'm going to take negative 3 and multiply it by 2x. So negative 3 times 2x is negative 6x. So this is minus 6x. And then negative 3 times negative 3 is going to be plus 9. So I'm making 6 different multiplications. Once I make those multiplications, then I'm going to add and combine my like terms. And so the answer to this is going to be 2x cubed. And then my x squares here, that's going to give me a total of 5x squared. So plus 5x squared. And then I have negative 12x minus 6x, so that's negative 18x, and then plus 9 for part C. Part D is taking f of x divided by g of x. So f of x is going to be, x squared plus 4x minus 3. And now this is divided by 2x minus 3. 2x minus 3. And there's your division. Now we haven't really talked about how to divide, actually like go through and divide this. One thing that we will learn later on is, if this top part could be factored, which it cannot be. This top part, or this red part, cannot be factored, but if it could be factored, we would try to factor that, and that might allow us to cross some things off here. But when you look at this red part divided by the blue part, you can't cancel off anything. You can't divide anything directly, because every term here is part of a larger group here. You have this whole x squared plus 4x minus 3. You can't do anything like, this 4x here and this 2x. You couldn't go in there and cross out these x's or something weird like that, because those x's are part of a larger polynomial, and so you can't just pick and choose those different terms and cancel those off unless they're standing alone by themselves. So actually D, you just leave it like that. You have x squared plus 4x minus 3, and then divided by g of x. So there's my answer. I will say here, if you're asked to find the domain of some of these problems, so like this one right here, if you were to think about this whole expression and you were to say, what's the domain here? What's the domain of that problem? Again, you'd be asking that question, what am I allowed to plug in for x? Right? What can I plug in for x? And so if you look at the red part, if you look at f of x, or you just remember quadratics, there's no restriction on the domain. You can plug in anything for x and it's all fine. If you look at the blue part, or g of x, separately, you have 2x minus 3, and again, the domain is all real numbers. You can plug in any number there and you don't have any errors. Now, since you're dividing them, a clear restriction, there's a clear restriction when you divide anything, and that restriction is that we have you can't divide by you can't divide by 0. Right? So I'm going to put this on the side. You can't divide by 0 ever, and that's true for any fraction, of course. So here, when we divide, we have a fraction, and we can basically say that same rule. Well, I can never divide by 0. So I like to call this a restriction. This denominator here, this 2x minus 3, the only thing I can't plug into x in this whole thing is I can't plug in, or the bottom, that 2x minus 3, cannot equal 0 as a whole. Because if 2x minus 3 was equal to 0, that means that I would be dividing by 0, and you can't do that, right? So I'm stating that right here. 2x minus 3 cannot equal 0. And you could simply solve this little equation here. So it's not an equation, actually. It's an inequality, right? So if I add 3 to both sides, I say 2x cannot equal 3, and therefore x cannot equal 3/2. So the domain, if you were asked for what the domain is of this problem, you would say you could plug in any number into this circled part right here. Any number would be fine, but the one number that wouldn't work would be 3/2, because whenever you have a fraction, which we have a large fraction here, you can't divide by 0, and that implies that 2x minus 3 cannot equal 0. So therefore, if you go ahead and solve this, that means that x cannot equal 3/2. So we'll kind of look at that throughout, but start thinking about that domain idea, what we can plug in and what can we not plug in.